Hello everyone, my name is Emmanuel. I'm a graduate student at North Carolina A&T Chemistry Department. Today I'm delighted to show you how to run Proton NMR. Please come with me. So we start off from here. This is our lab. This is where our NMR setup is. First of all, right, this one over here is our pump. The first thing you have to do is to make sure that this notch is on. You put it on and it starts pumping gas, basically nitrogen gas. So this is our tank. We have a gauge that tells you how much pressure is being built up. It is set up to control the pressure at average of 80 psi. So once you have our gas running, it goes right there through these tubes all the way to this chamber. And this right here is where our magnet is. And as we know, NMR is nuclear magnetic resonance spectroscopy. We do with magnets. And right here we have a huge magnet. We have a 300 megahertz magnet in there. And this is where we place our sample, right here. The nitrogen gas being pumped through here builds up some air that actually holds the sample, and I'm going to show you quickly how this is done. Now, when you come over here, this is our spectrometer, and that is our NMR system right here. That's the main brain of the whole setup, and this is where the magic takes place. This setup is connected to this computer right here, and this computer is where we have a software that will be used to run the whole process, and I'll be taking you through that as well. So the first step is to prepare your sample, and this right here is the NMR tube, and this is where your sample goes. You can prepare the sample in a beaker or any sample cuvette you have. Prepare your sample in there, or put your sample in there, dissolve it in any of the three solvents. You can use deuterated water, deuterated chloroform, or DMSO. Now once you have your sample prepared, then you fill it into this tube, the NMR tube. So over here you have sample status, and this is where you can actually inject or insert your sample, and I'm going to do that right now. I'm going to click on eject. We have a standard in the magnetic chamber. It's going to come off once I click on eject. So now I'm going to show you how to insert this sample into the magnetic chamber. So once you have your sample ejected, you can take it off, and just to demonstrate how the whole thing is done, this is the NMR tube. You have to be careful, it's very fragile. You can take it off carefully. That's a sample tube, and this is a sample holder. You also call it a spinner. So you put it in here carefully. Now the problem is you have to adjust it such that the sample is exposed to the magnetic field in the magnetic chamber. So there is a way to do that. This is our very own simple adjuster. That's how I call it. You place your sample spinner in here, and it has to be exactly within this range. So just push it slightly down until it hits the bottom, and you are good. So once you are done, then you have it set up the right way, and then you proceed to the magnetic chamber again. Then you place it in the sample tube right here inside the magnetic chamber. So you place it there, and as you can see, it is sitting comfortably on a cushion of air. Now we come back to the computer, and remember, you have to take off your gloves. Don't pollute the system. So once your sample is comfortably sitting on the cushion of air, you have to inject it. So over here I will click on insert. Now the first thing you do is that there is a start tab here. Click on it and click on standard. When you click on standard, there is a portion you have to enter the details of your experiment. So I'll put put in my sample name. I'll call it Ima. And then the log number is how many experiments are you running? Is it going to be 10, 2, 3, whatever? So this is my first experiment. And so I'm going to put 1 there. Now, the very important part is to select the type of solvent you are using. Here we are using deuterated chloroform, and so I will click on CDCl3, or you can select it from here as well. There is a drop down arrow you can select from. Once you are done with that, then you are good to go. Now the next step is to click on lock. Now the locking part is where you set all the NMR system is going to optimize the conditions to run your experiment. You have to set your Z0, which has to be on the right level. So you click on find Z0, set your parameters. So you go to the next tab, and that is spin or temperature. So you can set the spin speed, or you can set the temperature to run. It is set at 25 degrees, and I'm good. Once you're done with that, you click on acquire as the next step. Now over here, you can set the number of scans, and I will set my number of scans to 8. You can change it to 16 or 32. The higher the number of scans, the better your resolution. So once you are done with that, then you can click on acquire. Now make sure that it shows acquiring Proton, and then you can wait patiently for your spectrum. Great. So now we have our spectrum. Now this is the NMR spectrum for my sample. I'm going to take you through it quickly. Now once you have this, you can do whatever you want with it, analyze it, and as you can see, all these peaks represent different proton environments. And over here, you can zoom in. By clicking on this, you can actually zoom in on one of the peaks, click on zoom, and you have your peak. As you can see, this is a singlet between 7.3 and 7.2. This is representative of aromatic compounds. In this case, it is benzene ring. Now you can zoom out again. So whichever peak you want to actually get a closer look. Now here, over here, we have a peak or a chemical shift around 1.4, 1.6 thereabout. That is representative of a methyl protons. So you can actually zoom in to see how it looks like. My sample is actually ethyl benzene. Once you are satisfied with what you have, then you can click on process. When you click on process, you look out for plots, and then over here you have auto plot preview. You can have it printed out quickly, and that's it. This is your spectrum. It has every detail. The chemical shifts are here. The heights of your peaks are here. You can save it onto a file, and you are done. On this note, I end my presentation. It has been your man, Emmanuel from the Chemistry Department of North Carolina A&T. Cheers.